Eighth grade, greetings, good morning, salutations. We're about to go through some scientific notation. Little rhyme for you. You're welcome. You didn't see it coming, did you? All right, so here we go. I'm going to go through Ms. McRoberts' notes, and some of this you're going to have to write down, but I'm going to be lazy and not write it down because I've already passed this class. You are doing so right now. All right, here we go. Scientific notation. Numbers written in scientific notation are written as two factors. One factor is a number between 1 and 10. The other is a power of 10. I'm going to say that again, and then I'm going to show you what I mean. Numbers written in scientific notation are written as two factors. One factor is a number between 1 and 10. The other is a power of 10. So you've probably seen this before, so a little bit of this may be review. But increasing the power of 10 is the same as multiplying by 10. Here's what I mean. If you were to have 2.345 times 10 to the 0 power, okay? 10 to the 0 power. Well, what's anything to the 0 power? You should know this. 1. So essentially, we're not multiplying this by any power of 10, so it stays the exact same. Okay? Again, that one probably didn't help much because it literally didn't change. So, let's look at the next one. If I have 2.345 times 10 to the first, notice I'm essentially multiplying by a power of 10 once, so that's going to move our decimal 1. Notice how it moved it. 1 decimal place. Let's keep going because if some is good, more is better. I now have the same, and notice it's written the same way every time. It starts with the front number, right? Has to be between 1 and 10. Now let me just be even more specific. Technically it can't be 10, right? It has to be less than 10. So this number satisfies that times 10 to the second. Okay, now I have 2 powers of 10. That's going to move the decimal twice. And we get 234.5. Does everybody see how this is tracking? So the higher the power, that's how many times you're moving the decimal, which it's that many times you multiply it by 10, okay, or powers of 10. Make sense? Questions on that? So here's the thing also. So far we've multiplied by positive exponents. Negative exponents, if positive moves it to the right, making it a larger number, when I multiply by a negative exponent, it's going to become a smaller number. Let me give you a quick example of that. If I were to take 2.345, multiply that by 10 to the negative third. Okay, like I said, when I'm multiplying by positive powers of 10, it's moving the decimal. You see how it didn't move it here, moved it once, because it told me to move it once. Moved it twice, because it told me to move it twice. To the right. Now I'm multiplying by a negative exponent, meaning it's going to move my decimal 1, 2, 3. Okay? So I'm going to show that real quick off the left side. That means I'm moving my decimal 1, 2, 3, and those are going to become my zeros. So my final answer here would be 0.002345. Notice the difference between our positive and our negative exponents. Positive exponents make the number larger, meaning your decimal will go to the right. Negative exponents make it smaller, meaning the decimal will go to the left. Okay? That's a quick rundown on how to interpret scientific notation when they give you a number already written in it. Now, let's say they give us scientific and we want to go the opposite way, right? So far we've gone from scientific to what's called standard notation. Let's reverse it, okay? Let's reverse it. We're going to now go the opposite way. If I have to go standard into scientific. So let's think of a bigger number. Start off with a nice one. Let's say 132,000. And I gotta make that into scientific. Okay, so we're starting now with standard. We just went from scientific to standard. Now we're going from standard to scientific. Remember the rules. It has to be between 1 and 10, or technically less than 10. So the only way that I can make this number between 1 and 10 is to put the decimal right there. Right? That's where I'm going to have to put my decimal. Because if it's behind the 3, it's 13. Nope, that's too big. If it's in front of the 1, it's 0.13. Nope, can't do that. It's too small. So to represent this, I now have to go, okay, 1.32. You don't need to put zeros, right? Because if I put zeros back here, that actually has no place value. However, I really need to make sure I understand how many decimal places it moved. How many decimal places did it move? The decimal was here, and now it's behind the 1. So I moved 1, 2, 3, 4, 5. I moved 5 spaces. So to get from 1.32 back here, I'd have to move 5 spots. That's how I transition from standard notation to scientific. Let's do one more. The opposite a little bit. Let's say we have 0.00431. Okay? 0.00431. Again, I need the number in front to be between 1 and 10. All right, so now, where's the decimal have to go? Yes, there's announcements. Ignore them. It's got to go behind the 4. So I got to get 4.31 times 10. Okay, we moved it. Keep in mind, we moved a different direction. Moved a different direction this time. This one, to get to the 4, we had to move 1, 2, 3. Right? We had to move 3. Now, what you have to understand is, this isn't a positive 3 though. This one's going to have to be a negative 3. Because, how would you move this back to where it came from? It'd have to go to the left. Negative powers of 10 move the decimal to the left. Positive powers of 10 move the decimal to the right. Okay, so that's a quick rundown of how to go from scientific to standard and standard to scientific. It was quick, it was brief, hopefully it was wonderful. Hopefully it makes sense. Good luck.